If I asked you what the biggest problem of our time is, many of you would answer with a single word, without hesitation: battery life. Smartphones, laptops, and increasingly, electric vehicles. All of them are hitting the invisible but very real limits of battery technology that hasn't fundamentally changed for decades. Screens are getting bigger, processors are becoming more powerful, artificial intelligence is everywhere, but when it comes to energy, we are still chained to the charger. Our lives are accelerating, expectations are rising, yet batteries are struggling to keep up. But what if I told you that these limits are about to be shattered? Today, we're exploring a supermaterial emerging from research labs, one that has the potential to increase battery capacity by up to 5 times, graphene nanotubes. Welcome to the holy grail of energy storage. Graphene is an extraordinary material made of carbon atoms arranged in a single, atom-thick layer in a honeycomb pattern. Despite being one of the thinnest materials ever discovered, it is also one of the strongest. Graphene nanotubes are formed when the single layer is rolled into a perfectly seamless cylinder. The scale is hard to imagine, thousands of times thinner than a human hair. Yet their strength is remarkable, around 200 times stronger than steel. At the same time, they conduct electricity better than copper and are almost weightless. When you combine these properties, graphene nanotubes become something truly unique, a nearly frictionless highway for electrons. Electricity flows through them with minimal resistance. That's why placing these nanotubes inside a battery doesn't just improve performance, it fundamentally changes how the battery works. In today's lithium-ion batteries, there is a structural weakness. The active materials that store energy expand and contract during charging and discharging. Over time, they begin to separate from each other. This leads to reduced conductivity, the formation of dead zones inside the battery, and a steady loss of capacity. The battery ages, and performance declines. This is where graphene nanotubes step in. Inside the battery, they form a three-dimensional conductive network. Like a nervous system, they connect every particle of active material, ensuring electricity can flow evenly and efficiently everywhere. Conductivity losses are minimized, and the battery can maintain near-original performance for much longer. Another crucial advantage is volumetric efficiency. Graphene nanotubes are so incredibly thin that they take up almost no space inside the battery. This allows engineers to pack far more energy-storing material into the same physical volume. The result is dramatic: a battery with the same size and weight can deliver up to 5 times the capacity of conventional designs. That means using a smartphone for weeks instead of days on a single charge. Or an electric vehicle traveling not just between cities, but across countries without recharging. But capacity is only part of the story. Perhaps the most exciting impact of graphene nanotubes is on charging speed. Electrons move extremely fast through these nanotubes, which significantly lowers the battery's internal resistance. Lower resistance means less heat generated during charging. Less heat means less energy loss, longer battery life, and dramatically shorter charging times. Fully charging a battery in minutes, or even seconds in certain applications, is no longer science fiction, but an emerging laboratory reality. And a battery that doesn't overheat is also a much safer battery. The risks of fire or explosion, common concerns with traditional lithium-ion cells, are greatly reduced. The implications go far beyond consumer electronics and cars. Electric aircraft, advanced robotics, autonomous systems, and large-scale energy storage facilities could all be transformed by this technology. One of the biggest challenges of renewable energy, such as solar and wind, is efficient storage. Graphene nanotubes could enable safer, denser, and longer-lasting energy storage, helping stabilize power grids and accelerate the transition to clean energy. Today, from Tesla to Samsung, the world's largest technology and energy companies are racing to commercialize this material. What we're talking about isn't just a better battery, it's a shift in how we think about energy itself. Energy is slowly becoming less of a limitation. So here's the question: when the battery problem is finally solved, what do you think will be the first thing in our lives to truly change? Let me know in the comments.